SR NAND latch flip-flop. So here also we use a set reset NAND latch flip-flop implement with the two NAND gates. We use NAND gate truth table to implement NAND RS latch. So just look at the input NAND gate A, the input is S, that means set and Q bar. Then it will give the output Q. That Q will be an input for the B with the reset. So output becoming Q bar. So that output again will go to the gate A as input and set input, then output will be Q. That Q will be input for the B and reset. Then output will be Q. Okay. And the truth table 0, 0 is invalid. Earlier 1, 1, opposite of that. 0, 1 means set. The output will be 1 and 0. Then 1, 0 means reset. අර කලින් එකේ opposite විදිහට යන්නේ. ඉස්සෙල්ලා මොකක්ද උනේ? එක set එකේදී S එක වුණානේ. මේකේ set එකේදී එක බිඳුවයි. reset එකේදී reset එක බිඳුවයි. හරි. memory එක එකේදී යන්නේ. මෙතන 0 0 out invalid state එක. ඒතර on එක තමයි වෙන්නේ එතන. හරි. ඉස්සෙල්ලා note එක ලියලා මේක අදින්න. ලියන්න ගන්න ඉස්සෙල්ලා. ඊට පස්සේ truth table එක අදින්න. truth table එකේ තියෙන්නේ SS invalid 0 1 1 0 in output QQ bar, then S1 R0 again 0 1 S1 R1 memory, previous memory. Okay, shall we copy this? We call this as SR latch. Okay, this is NAND gate flip-flop. So latch flip-flop, SR NAND gate flip-flop. So in the beginning, all inputs are on. So I'm going to change that. That means all inputs are 0. So 0, 0 mean invalid state. Just look at 0, 0 mean invalid. Invalid mean 0, 0. That is switch on. Then that means not in use. That's an error. Why? Q also on, Q bar also on. Can't be. Therefore, we call this state as invalid state. If Q is 0, then Q bar should be 1. Okay. So this is invalid. And then S0 R1. Now see what is happening. S0 R1. What will be the output? 1, 0 should come. Now look at, I'm going to change the reset into on. Look at the screen. Changing reset into on. So output becoming Q1. Yes. Q bar 0. Then I'm going to change S on R0. I'll make R0. S on. S on R0. That is reset. So output Q will be 0. Okay. Our output Q bar is 1. Then again 1, 1. 1, 1 means calling the previous memory. Now we have 0, 1. Q is 0. Q bar is 1. So I'm going to make both 1. Q is 0. Q bar is 1. Okay. Can you understand the states? Then each and every state I have taken. So 0, 0. 0, 1, you will get Q1, Q bar 0. No need to draw this. Previous memory is called by the 1, 1. So that means if Q is 1, it will call the previous memory. S is 1, R is 1, then previous memory Q will call back as the input. Then output will be coming again Q1, Q bar is 0. And we can draw a graph again. Okay, look at this graph. NAND gate flip-flop. S is on. That means S0 are on. Output becoming 1. Like we can change. I'll give you nice. One I took as memory. So if we have one mean holding memory, previous memory is calling. One calling the previous memory. Again here calling the previous memory. Okay. Then if we have set 0, 1, set S is 0, R is 1. Set reset change according to the type of graph. So set 0, R1, then Q is 1, Q bar is 0. Another set 0, 1, then Q is 1, Q bar is 0. 0, 1, Q is 1, Q bar is 0. Reset. Set is on. Reset is 0. Set is on, reset is 0. Then Q is 0, Q bar is on. Okay, that's all. So shall we complete the graph? Invalid mean if both 0, invalid. I didn't give anything like that. If it is there, then invalid output 1 will come for both. Try draw this graph and find it out.